Okay, so yesterday we started 4, which is trig functions of any value. That the radius now can change, it's no longer 1. And so you can use these ratios, or you can just use your SOHCAHTOA that you already know, which is the same. We talked about, we refreshed on the degrees and radians measures. We talked about the quadrant angles. These are ones that you cannot find with a right triangle because, especially with its 90 degrees, you obviously can't find the opposite side and the hypotenuse. Those would be the same thing. So these are ones you would have to have your unit circle for or know your quadrant angles for. And then we worked through example 1 and example 2. We left off here, which is the signs of the trig functions. So there is an acronym that you can use to help you remember what's positive in each of the quadrants. Your book gives you these, like as all students take calculus, and that stands for A for all of your functions. S, which is sine, and if sine is positive, so is its reciprocal function, which is cosecant. T for tangent and cotangent, and C for cosine and secant. So as you move around your unit circle, you can use that same thing. All students take calculus. They also say all snakes tease chickens, a smart trig class. So now when you start to think about those corners, so some of you did it when you filled out your unit circle, the positive and negatives in the top you put in terms of trig functions. But here on out, instead of putting x and y, you wanted to focus on the trig functions there. So here's some application. It says name the quadrant in which theta lies if the cotangent of theta is greater than 0 and the sine of theta is less than 0. So if, again, you think about all students take calculus, that's what's positive. For my cotangent to be greater than 0, it means my cotangent's positive, right? Which means my tangent is also positive. So based on what I already have, tangent is positive in the first quadrant and in the third quadrant, which means I'd rule out quadrant 2 and quadrant 4. And then the second part of this says sine is less than 0, which means sine is what? Positive or negative? Less than 0 would be negative. So in the first quadrant, they are all positive. I rule that out. And then the third quadrant, sine is negative, tangent is positive. So I know that this is talking about the third quadrant. Sometimes you could have more than one quadrant, like you'll see in the homework, it might say quadrants, plural, okay? You can have more than one answer, but this is just that individual quadrant. All right, example 4 says, given that the cotangent of theta is negative 4/3 and the sine of theta is greater than 0, find the following. So now we're going to use the first piece of information to set up a right triangle. I'm going to put theta in the corner. And I've got cotangent. This is going to be adjacent over opposite, so 4 and 3. Now the question is the negative on the 4 or the negative on the 3? And that's why the second piece of information is there. Because sine is positive, that means opposite over hypotenuse has to be positive, yes? And what do we say about the hypotenuse?
It's 5.
It's 5, and it's always positive. So for sine to stay positive, that means the 3 has to be positive. For cotangent to be negative, that means the 4 is the one that gets the negative. So they're always going to give you just enough information for you to figure out your positive and negative signs on your triangle. Because obviously if you're given opposite and adjacent, that could have been negative 4/3. That could have been 4 over negative 3. The negative could go with either one. You've got to figure out which side based on that second piece of information. Now you've got a complete triangle. So the sine would be 3/5. The cosine would be negative 4/5. The secant is the reciprocal of cosine, so negative 5/4. And the cosecant is the reciprocal of sine, so 5/3. So the triple on the triangle gets you half of it, but the signs are obviously important, the positive negative signs. Questions on that one? All right, example 5 says the terminal side of theta lies on the given line with the specific quadrant. Find the values of the 6 trig functions of theta by finding a point on the line. So this is actually a line, right? Y equals 3x is in y equals mx plus b format. I'm going to pull in graphs so that we could be accurate. So if I wanted to graph y equals 3x, where do I start?
The origin.
At the origin, and then the slope, if it's 3x, the slope is what?
3x
3. So I'd go up 3 and to the right 1. So there's the line. And it says that the terminal side of theta lies on that line. So if this is my initial side, that's my terminal side, I can draw a little triangle and then find the values of the 6 trig functions. So if I cut it off at the point that I actually drew, then my triangle looks like this. And my slope was 3, right? So what's the horizontal distance? From here to here would be 1. The vertical distance, 3. Now I've got a right triangle. And I got to find my hypotenuse, 1 squared plus 3 squared, which is 10. And C is root 10. And then from there, I can get all my trig functions. So sine is 3 over root 10, which gets rationalized. God bless you. 3 root 10 over 10. Cosine, 1 over root 10, which also gets rationalized, root 10 over 10. Tangent, 3 over 1, or 3. And then the reciprocal functions. So I'm going to flip the sign before I rationalized it. Root 10 over 3. Flip the cosine before I rationalize it. Root 10. And then the cotangent would be 1/3. Questions on that one? So the slope will obviously always tell you your rise and your run. That's always going to tell you the change in x, the change in y. That's the 2 legs of your triangle. And then Pythagorean theorem will get you the 3rd leg, or 3rd side, which is your hypotenuse. And then go from there. Okay, this says evaluate the trig function, or the trig function of the quadrant angle if possible. So now we're dealing with quadrant angles, right? We cannot set up right triangles with these. This is where you have to have your unit circle. So I know moving around my circle that this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. This coordinate point is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So when it says the sine of pi, I'm going to where pi is, which is over here, and sine is which coordinate? The y, so this would be 0. And then this should be over here. The cotangent of 3 pi over 2, cotangent is x over y. 3 pi over 2 is down here. This would be 0 over negative 1, which is 0. So it says if possible, because if that had asked for tangent, it would be undefined. That's what the if possible means, okay? It could be undefined, and if that's the case, you literally just write undefined. Still good? Okay, reference angles. So a reference angle of theta is the acute angle theta prime. That little apostrophe means prime. Or it's read as prime, is formed by the terminal side of theta and the horizontal axis. So you're always doing the distance from where it stops, where the terminal side is, to the x-axis. To find the reference angle, you're going to find the difference between the angle and the x-axis. So if you could picture your coordinate plane, if my angle is in the first quadrant, I want the distance from the x-axis to the terminal side, and theta is going to be the same as the reference angle. So first quadrant, you don't have to do anything. The answer is what it is. If it's 30 degrees, the reference angle is 30. If it's 42 degrees, the reference angle is 42 degrees. 89.9 degrees, it's still 89.9 degrees. If it's in the second quadrant, then I want to find the difference. Oh, sorry, no, so it would be here. The initial side's still there, but the terminal side's in the second quadrant. Here is theta. The reference angle falls inside here. So you do 180 minus theta, or pi minus theta. So if my angle was like 100, I would do 180 minus 100, and I'd get my reference angle as 80. Then,
Is the reference angle the one on the bottom or the one on the top?
the reference angle is here, that theta prime is there. Yeah. If it's in the third quadrant, then same initial side, but now my terminal side is somewhere in the third quadrant. That's theta. Theta prime is the distance in between the terminal side and the x-axis. So this time I take theta and I subtract 180 from it if it's in degrees, or I subtract pi from it if it's in radians, and that gives you theta prime. And then the last one is if the, again, terminal angle is in, or sorry, the initial point is still on your standard place, so it's still at 0, but now my angle comes all the way into the fourth quadrant. So that's theta, and the difference between that and the x-axis is theta prime. So to do that, I would do 360 minus theta, or 2 pi minus theta. These angles must always be greater than 0, but less than 90. I did that the other way around. So if you go to write a reference angle that is 91 degrees, it's wrong. It can't be negative, it can't be bigger than 90, which means it can't be bigger than pi over 2. It actually can equal, nope, not equal 0, but it can equal pi over 2 and 90. So again, if you ever go to write an answer for a reference angle, it's bigger than 90 or bigger than pi over 2, it's wrong. Less than 0, it's wrong. It's got to be in between those two things. Anybody still copying that down? So now this says find the reference angle theta prime and sketch theta and theta prime in standard position. So if I look at theta being 2/3 pi, and I go to graph that initial one, obviously my standard is here. Is 2/3 less than a half or bigger than a half? Bigger than a half. So I know it's over here. If you know your unit circle, you'll also know it's over there. That's theta. So it's in the second quadrant, which means how am I going to find theta prime? I'm going to do pi minus 2 pi over 3. Or 3 pi over 3 minus 2 pi over 3, which is pi over 3. I need to find the distance between the angle and the x-axis. So theta prime is actually pi over 3. This is theta. I don't know why I wrote that there. The blue is the original theta, and theta prime would be pi over 3. So all of my reference angles should be located where when I graph them? What will be true about every angle that's less than 90 degrees? It'd be in the first quadrant. All right, 9 pi over 2. So this time I've got something that's bigger than the 2 pi. Convert that to mixed number. God bless you. What's 9 pi over 2 in mixed number format? What's 9 pi over 2? Well, what's it in mixed number?
Oh,
4 pi over 2, or 4 and 1/2 pi, right? So when I graph this original angle, it starts here. Remember, 4 would bring me all the way back around to the right side because it's a whole number. It's actually going to double around. But it's going to come all the way back, and then it's going to go to the 1/2 mark, which is all the way up there at the top. That's theta. Now, what's the distance between that and the x-axis? 90 or pi over 2. Yep. Sort of. I mean, when it's like this, it's almost even coterminal. God bless you. It just depends on if it goes outside of your circle. So, I mean, the thing is that it's always a cube, or 90 or less, because it could be 90. It's a right or a cube. And it's always the distance between that and the x-axis. So it's basically what we did with our triangles yesterday. We always go up to the x-axis. but it's always positive. It's always going to be less than or equal to 90, that kind of thing. Which means you can use your special right triangles on all of these. That's the idea behind them. Okay, this one says, find the sine, the cosine, and the tangent of the angle without a calculator. So we're going to try to do this. Obviously, you could do this if you had your unit circle, but we're going to try to do this with a reference angle. If I had 5 pi over the 4, which is just past 1, what would be the reference angle? I would have to subtract, right, from pi. I'd go minus pi, 4 pi over 4, and that's pi over 4, right? That's my reference angle. Everybody with me so far? What's the coordinate point at pi over 4? What's the coordinate point? Root 2 over 2 and root 2 over 2. So that part I already know from the over 4 part. Now, if you think about all students take calculus, what's going to be true about the trig function sines of my 5 pi over 4? What's positive? Tangent and cotangent. God bless you. So now I know that these are positive and I know the rest are negative. And because I already know that coordinate point, I can fill those in pretty easily. This would be root 2 over 2, root 2 over 2, 1. And then this is root 2, because if I flip it, right, if I take this and flip it and rationalize it, I get root 2. Same thing here, root 2, and cotangent and tangent are both positive 1. I think, oh, did he come back? Yeah, he came back, yeah. All right, so basically that is a unit circle angle. You could have used your unit circle, but obviously we're going to move to be outside of our unit circle. And so it might ask you for the reference angle, and it might ask you for the point. And we didn't even need these because it didn't ask for it, but it's good to know how to find them. All right, now it says use a calculator to evaluate the trig function and then round your answer to 4 decimal places. So we're back to the calculator. This, again, should be super easy. You just have to pay attention to the mode of your calculator. And again, a reminder for your test that you will be able to use the calculator on the portion of it. Obviously, that would look like this. So what mode does the first one have to be in? Radians. There's no degree symbol. So it's 1 over the tangent of 4.3. And again, it's got to be in radians. You should get 0.4375. And then secant of 213 degrees means it's in what mode? Degrees, 1 over the cosine of 213. Negative 1.1924. So those should be easy gimme questions. Obviously, you just got to make sure you pay attention to the rounding instructions and that you're in the right mode. What stinks about those is you get it wrong because the wrong mode, there's no partial credit. It's totally wrong. There's no work you can show there. So it's important to make sure you're in the right mode. Questions on that one? Yep.
If you were in radians, but you put like secant.
And you put the degrees. The smart calculators know that. Yeah.
It'll work either way.
Yeah. Some, like the graphic ones. Yeah. Yeah. Okay, example 10 says find 2 solutions of each equation and give your answers in degrees and in radians. Don't use a calculator. So this time this is actually the reverse. I am telling you what the sine or the sine is in this case. You need to give me what angle it would match. So I'm going to pull in the unit circle so you have a visual on this. Okay, so the first one says A is sine theta equals 1/2. So if I look at my unit circle, I'm trying to find sine, which is which coordinate?
Y.
The y. I'm trying to locate where on my unit circle the y is a positive 1/2. Where does that happen? At 30 degrees or pi over 6 and 150, 5 pi over 6 or 5 pi over 6 or 150 degrees, right? So it says give your answers in degrees and radians. In degrees, it would be 30 degrees and 150 degrees. And in radians, it would be pi over 6 and 5 pi over 6. So this is actually like baby stepping our way into inverse trig functions, which is the last section in the chapter. We'll get back to this. But for right now, you're just going to do what it says to do. So then B says the sine of theta equals negative 1/2. So where on my unit circle is the y negative 1/2? 210 and 7 pi over 6, or 330 and 11 pi over 6. If it had said cosine, I'd be looking for the x value. If it had said tangent, I'd be looking for the tangent value. Remember that the tangent, this is why it's kind of like important to know the tangent, easier to know the tangents, would be root 3 over 3 at the over 6. It's 1 at the over 4, and it's root 3 at the over 3. So if you haven't memorized those yet, it makes your life a lot easier when we're moving forward. You want to know those as well. Okay, last one. This says the displacement from the equilibrium of an oscillating weight suspended by a spring is given by y of t equals 2 sine 6t, where y is the displacement in centimeters and t is the time in seconds. Find the displacement when A, t is at 0, B, t is at 1/4, and C, t is at 1/2. So this is your real world application. A lot of times anything that has a consistent motion up, down, you can make a sine curve from. So waves of the ocean, they can make a curve from. Something like this where a spring and it's going up and down the same distance. That's like something that you can make an actual curve from. You can come up with a function. So they already did that for you. That's the easy part, okay? They gave you the trig function. So if t represents time in seconds and you want to find where t is 0, what do? What variable becomes 0? T. So I would get 2 times the sine of 6 times 0, 2 times the sine of 0. What is the sine of 0? 0, right? The y on 0 would be 0. So 2 times 0 is 0, which should make sense. The displacement doesn't start, right? It starts at 0, okay? Then you would like a weight would then pull it down. So that's A. B says t is 1/4. So I'm going to do 2 sine 6 times 1/4. 2 sine, this becomes 3/2. Now is that an angle on your unit circle? There's no pi there, right? If the pi was there, then it's on your unit circle, right? 3 pi over 2. Yes, does that make sense? But the pi is not there, so this is 1.5. But it's still in radians because it doesn't say anything about degrees. So I just use the calculator for that one. I would say 2, again, I'd be in radians. 2, go back to radians. 2 times the sine of 3 over 2. And I get 1.9949, so 1.9950. If you have a question like this on your homework, I think it says to round, and then same thing for the test. It would say to round. So you could see this on both, like the calculator and the non-calculator part. Calculator part, it wouldn't have a pi like we just did. Non-calculator part, you would have a pi in the equation, so you'd be able to find the sine of that trig function, or that sine of that angle. All right, and then the last one says t is 1/2. So 2 sine of 6 times 1/2, 2 sine of 3. Again, that's not on your unit circle, so you're going to use the calculator. 2 sine of 3, and I get 0.2822. So the displacement, again, is if you've got a spring and you've got a weight that's pulling it down, it would obviously go down, it'd bounce back up, it'd go down, it'd bounce back up, and that starts that curve. So at t being 0, it's at 0. At t being a fourth a second, it's 1.9950, and at t being a half a second, it's 0.2822. Questions? Lively bunch as per the usual. Yeah. Okay.